So hello everyone, in today's session I'll be explaining the difference between Big Endian and Little Endian processors or controllers. Okay, before I explain in detail about what these are, what we should know is that Endianness basically focuses on how exactly you're storing the data in the memory. Okay, so based on that itself, there are two categories, one called as Little Endian, one more called as Big Endian. Okay, so it's only about the way in which data is stored in the memory. Okay, now I'll just read out the definition given here. After that, I'll explain in detail with a certain example about what exactly is the difference. As specified here, higher order of data byte if it is stored at higher memory, okay, and lower order of data byte at location below the higher memory, then it is called as Little Endian. Okay, while lower order of data byte if it is stored at higher memory and higher order of data byte is stored at location below the higher memory, then it is called as Big Endian. Now these words may not seem very clear as of now, but first thing you should know to understand about the Little and Big Endian is how exactly the memory is designed. Okay, if you consider this as your memory, okay, memory is nothing but storage area. Okay, and let's assume in each box specified here you can store some data. Okay, then when you say multi-byte system, it means that in each location you can store 8 bits. Okay, 8 bits here, 8 bits here, 8 bits here, because 1 byte is nothing but 8 bit. Okay, so you in the memory you store 8 bits in one location, that is nothing but 1 byte in one location each. Okay, now let's go to the example now. Okay, let's consider the data which we want to store in the memory is 0x1 2 3 4 5 6 7 8. If you see the x symbol here, it means it is hexadecimal value. Okay, so here what 1 2 3 4, if you write in binary, this is its data. Let's start from this side. Okay, the least significant byte here. Hexadecimal 8 in binary is 1000. Okay, that is, it occupies 4 bits. Okay, these are 4 bits. Okay, 7 is split as 0 1 1 1. Okay, so this is nothing but one more 4 bit of data. This total constitutes 8 bits of data. Similarly, if you check any hexadecimal value, okay, every 2 hexadecimal value will require almost 8 bits in binary. Okay, so if you group it together like this, 1 2 will be stored in one memory location, 3 4 in one more memory location, 5 6 in one more memory location, and 7 8 in more memory location, since each memory location can only hold up to 8 bits of data. Okay, I hope this part is clear. Now let's come to the difference between Big Endian and Little Endian. Okay, so this is nothing but memory address. What do you mean by memory address? So I told your entire memory, okay, if you consider here, it is split into a multi-byte system where each location you can store 8 bits of data. Now if you once you have stored, or to get that data back, you need to assign some address. Let's assume this location is 0 0, this location is 1, this location is 2, this location is 3, here it is 4, 5, and so on. Okay, why is this required? If I have stored data in this particular location, to access what value is stored, you should know what exactly is its address. Okay, so that is the address specified here. What I have written is in the address 0x00, the initial, very initial location, if it is Little Endian system, and if the data to be stored is this, that is 0x1 2 3 4 5 6 7 8, then value 7 8 is stored in the lowest memory location. Next to that we have value 5 6, which is stored in first location, 3 4 in second location, and 1 2 in third location. So what is happening in Little Endian system? Okay, the lowest byte, okay, in this entire data, the least significant byte is 7 8, the most significant byte is 1 2. Okay, so if least significant byte is stored in the lowest memory location, then it is called as Little Endian. Okay, if you see, all next values are stored in the higher memory locations. Okay, if you see in the Big Endian system, the least significant byte is stored in the highest memory location. Okay, and all the next, follow the same order. Okay, so if least significant byte is stored in the lowest memory address, it becomes Little Endian. If a most significant byte is stored in the lowest memory location, then that is called as Big Endian. Okay, so that is about Little Endian and Big Endian.